Hi folks, here we are back at it again. All right, hopefully you've got your own self-made little notes packet here. We're going to start the day off with these notes on triangular prisms. So first of all, I just want to kind of backtrack a little bit and go back over what it is that makes something a triangular prism. So how will we know when somebody's a triangular prism? Well, remember from the previous video that a triangular prism is going to have two bases in the shape of triangles. So two triangular bases, and the sides are rectangles. So to draw a picture of my triangular prism, I would start by drawing my two triangular bases first, and then I would connect all of those vertices. So not fancy, but again, you can see the base here at the top and the bottom, in the front, the right side, and the left side that are rectangles. And in this video, we want to talk in particular about how we find the volume of a prism. And if you think back to middle school or maybe even elementary school, volume is the amount of space inside a figure. Or the amount that something can hold. You might think about water in your swimming pool. That's a really nice example. So it's the amount that's contained inside of something. It's always going to be measured in cubic units. And in order to find the volume of our triangular prism, we're going to use a formula. So volume is equal to area of the triangular base. And I'm going to represent triangular by doing a little triangle. Area of the triangular base times the height of our prism. And you know that as mathematicians, we love to abbreviate things. So this area of the triangular base, I'm going to represent with a big B or a capital B. And that's important. Big B is not the same as lowercase b. And height, we're going to use a lowercase h. So in other words, volume is equal to capital B or uppercase B times lowercase h. And I know that you're dying to get started here, so let's go ahead and let's look at an example of how we would find the volume of a triangular prism. So I'm going to call this example 1. And our goal is going to be to find the volume. And I'm going to start with this nice little triangular prism. So there's my two triangular bases. I always start by drawing those bases. I'm no artist, but even I can draw well enough to get this job done. So I'm going to say that that triangular base in the front has a height of 8. Its base length is 12. And I'm going to say that the height of my prism, which is the distance between the two triangular bases, is going to be 5. So the first thing that I'm going to do is I'm going to find the area of that triangular base. And if it's helpful, draw the triangle. So here's my triangle. I've got 8 and I've got 12. And I should put a little right angle in there to indicate that that is indeed the height. So the formula that we use to find the area of a triangle, 1/2 times base times height. So my base of my triangle is 12, height is 8. And I'm going to get my calculator out and I'm going to type in 1/2 times 12 times 8. And when I type in 1/2 times 12 times 8, my calculator tells me 48. So the area of my base, 48 square units. The next thing I need to know is the height of my prism. And the height of my prism is going to be the distance between the two triangular bases. So in this picture, I've got a triangular base at the front and a triangular base at the rear. And the distance between those two triangular bases is represented by the 5. And once I know the area of that base and I know the height, now I'm going to substitute in the formula. So the formula says volume is equal to area of the base, big B, times height. Well, area of the base we decided is 48. Height we decided is 5. And when I multiply the 48 times the 5, I end up with 240. We weren't given units for this problem, so I can either say that this is cubic units, or I can say volume is equal to 240 units cubed. Either one of those would be a nice acceptable way to write that answer. The important thing to note is that it's the same 3 steps every time. We find the area of the triangle, we find the distance between the two bases, and then we substitute into the formula. Always the same 3 steps. All right, I know you're anxious, so let's go ahead and let's try another one. I'm going to call this one example 2, surprise of all surprises. So this one I'm going to make my triangular bases a little bit different. I'm going to make my triangular bases right triangles. So I'll make these right triangles. Maybe I'll make this one 5 inches. I'll give them some units this time too. 12 inches and 4 inches. All right, it's always those same 3 steps, always. So step 1, find the area of the triangular base. And if it helps, draw your triangle. My base is a triangle that's 5, that has legs of length 5 and 12. So area of a triangle is 1/2 times the base times the height, or 1/2 times 5 times 12. Making the area of the triangular base 30 square inches. Step 2 is to find the height of the prism. And remember, the height is always the distance between the two triangular bases. So I'm going to go to the picture, and I'm going to find the segment that represents the distance between those two triangles. And that distance between the two triangles is 4. And now I'm going to substitute into the formula. So formula says volume is equal to area of the base, or big B, times the height. So 30 times 4, or 120. And I can either make this cubic inches, or I can make this 120 inches cubed. That's good work right there. Beautiful. We're going to tackle one more. Same idea. We're still going to start with a triangular base. I'm going to call this one example 3. I'm going to say that this piece here measures 3. This piece here measures 4. And this piece over here on the left side is 2. Well, you guessed it, folks. It's the same 3 steps. First thing I'm going to do is find the area of the triangular base. And again, if it's easier, draw that triangle separately so that you can really kind of pay attention to the dimensions on the triangle and don't get mixed up with some of the other things that are going on in the picture. So area equals 1/2 times base times height. So when I substitute into the formula now, I've got area equals 1/2 times 3 times 4. And when I plug in 1/2 times 3 times 4 in my calculator, I end up with 6. Step 2 is to find the height of the prism. And again, remember that height is really the distance between those two triangles. So when I go look at the picture, the distance between the front triangle and the back triangle is 2. That makes my height here equal to 2. And then lastly, substitute into the formula. So volume in this case is equal to area of the base times the height. Well, the area of my triangular base we said was 6. My height here was 2. So the volume here is 12 cubic units. Or if you prefer, 12 units cubed. Folks, I can't tell you how happy Miss Andre and I are with you right now. We know that the distance learning is hard. We really, really appreciate the fact that you're making an effort to tune in every day and to get your work done. Um, and you've really made some great progress. This stuff is not easy even when you're at school, and you've really, really impressed us with what you can do with the distance learning. So we know it's not easy, but we want you to know that we appreciate your efforts. Keep up the good work. We're getting there. We're almost to the end of the school year, and you can do it. All right, so keep on keeping on, and we'll see you at the next video. I miss you, folks.